All right, chapter 16, number 54. Second last question on your handout for those lab questions you did a few weeks ago. Chapter 16, number 54 says quinoline is a base in water, and it gives you the structure for it. It's a double ring. We call it a fused ring. Yeah, 6 members as well. But this one's heteroatom because there's a nitrogen. And then when we add our double bonds, there's one here, 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 and here, alternating. So this is called quinoline. So you don't really hear that word amine, but at least you hear this little suffix -ine. So this is quinoline, and this is an organic base. Again, 2, 4, 6, so 8. It does have a lone pair of electrons, so that's where it would accept a proton. A handbook lists the Ka as 6.3 times 10 to the minus 10 for its protonated form. Okay, so for its conjugate acid. And the question says, write the ionization, which is the dissolution in water, reaction for the protonated quinoline, the acid, in water. Okay, so the protonated form then is going to be, this is sort of like those questions, quickies that we did in class where we said, here's the base, write the conjugate acid. I didn't draw my 6-membered rings very well here. Okay, so that's the base form, so then I'll turn that into an H+, and there's the protonated form. So it's exactly the same molecule, you just draw it with an H+ on it. So they want us to write this in water. So if you're asked to do this on the exam, you're given a molecule and it says to write the ionization reaction, don't abbreviate it, write out the whole molecule, just to be on the safe side. So because this is an acid now in water, it would be governed by a Ka, and the acid will form its conjugate base. We'll draw it on this side a little bit better. There we go. And the double bonds are still all in the same spots. Okay, so I'm back to the basic form, and it gave away its proton. And this is why this guy is an acid in water, because it ends up creating H3O+. So that's the answer. And it also asks, what is the pKb for quinoline? What is the pKb for quinoline? Okay, so this is the protonated form of quinoline, so that's the acid. And if I were to write the base in water, and let's just do it, double bond, double bond, double bond, double bond, double bond. Okay, let's put this in water. That's a base, so it's governed by Kb. And it would form base, so this would be the acid, and it took that proton from the water, leaving behind OH-, so that's why it's a base, because it creates this in water. Okay, so it says, what is the pKb for quinoline? Quinoline Kb. Well, we know that the Ka times Kb for a conjugate acid-base pair is equal to 10 to the minus 14, right? And so a pKa plus a pKb is equal to 14 for the conjugate acid-base pair again. So they told us what Ka is, and they want us to find out pKb. Okay. Given Ka 6.3 times 10 to the minus 10. So there are at least two ways you could do this. The pKb would be equal to 14 minus the pKa, and the pKa is the negative log value of 6.3 times 10 to the minus 10. And when I do that on the calculator, I get an answer of 4.8. Just check that. Yeah. So I said there were two ways that you could do it. You could have also done that Kb is equal to 10 to the minus 14 divided by 6.3 times 10 to the minus 10. That would have given you a Kb of 1.58 times 10 to the minus 5. And then you would take the negative log of that, and you would arrive at 4.8. So how you do it is up to you. Just remember that the product of Ka and Kb is 10 to the minus 14, and the sum of pKa and pKb is 14. And again, we're talking about conjugate acid-base pairs. Great.